Hello everyone! Thank you so much for joining us today for a very exciting webinar on RSCAD FX, the new and improved real-time simulation software for the RTDS Simulator. I'm Katie Sidwell from RTDS Technologies, and I'll begin today with some housekeeping notes as usual, and then I will present just a few slides to introduce the product and the software. But most of the webinar will be a screen share demo, where I'll give you a tour of RSCAD FX and show off some of the new features and capabilities. We'll be ending with a Q&A period where myself and one of our simulation specialists, Gregory Jackson, will be available to answer your questions, of which I hope there will be many. And we'll be able to share our screens during the Q&A as well, in case we need to demonstrate anything in the software. A few housekeeping notes. Please feel free to submit your questions throughout the webinar. You don't need to wait until the end. You can submit them via the Q&A panel, and we'll try to answer some questions via text throughout the webinar, and any questions that require a demonstration, we'll do that for you at the end. As always, a recording of this webinar, as well as a document with all of the Q&A information, will be made available on our website next week. And we'll let you all know by email when that happens, so don't worry, you'll be notified. I'm not going to spend much time on introducing our technology or our company today, but we will have another webinar in about a month, and it's focused on energy storage, but it will also provide a really good background on the technology. So if you're new to real-time simulation, I encourage you to visit our website and sign up for our next webinar, because that one will be much more of a backgrounder. All right, without further ado, I just want to remind listeners of a couple of fundamental things about the RSCAD software. One, it's an electromagnetic transient, or EMT, simulation software. So RSCAD provides a time-varying instantaneous value output. And this differentiates EMT tools from other power system simulation approaches, for example, load flow, phasor, or RMS solutions. EMT simulation allows for a greater depth of analysis over a wide frequency range and the ability to reproduce fast transients on the power system, as well as the ability to represent the low-level controls of converter-based generation sources, which are so common in the modern power system, versus the conventional system that was more dominated by rotating machines. The simulation time step defines the time between two consecutive outputs, and typically for EMT simulations, that's around 25 to 50 microseconds, or 1 to 3 microseconds for representing the high-frequency switching of power electronics. The RTDS simulator runs this EMT simulation in real time, meaning that the time for an actual power system event to take place, such as a fault, is the same as the time required to simulate the event. It's no shorter and no longer. Real-time operation is what differentiates the RTDS simulator from other non-real-time EMT simulation tools. Real-time operation allows for a unique type of device testing called closed-loop or hardware-in-the-loop testing. We aren't showing any hardware-in-the-loop testing in this webinar because we're really just focusing on our software, but HIL is being used more and more in the industry as the interactions between devices becomes less certain and system-level testing of multiple devices at one time becomes more important before systems are deployed. So the software you'll see today is not just modeling the power system, it's also enabling this type of testing of protection, automation, control, and power devices. While non-real-time EMT simulation programs can run on your PC, maintaining real-time like we do requires dedicated computing hardware. So the RTDS simulator uses a dedicated parallel processing system, which is shown here. Our current hardware generation is called NovaCore, and it's based on IBM's Power 8 multi-core processor, and we've adapted that processor for our application at the embedded level. So when I run the demonstration, you'll see the software side of things on my PC, but you're not seeing the specialized hardware that the executable code actually runs on, which I'm connected to via Ethernet. There's also often input and output hardware involved, not in today's demo, but in general, for connecting the simulator to external equipment. All right, on to details about RSCAD FX. RSCAD FX was built in Java FX, hence the name of the software, and it was launched on April 6th, so it's been available for a couple of weeks now. Prior to this, there haven't really been any major changes to the graphical user interface since the initial release of RSCAD. So we've spent a long time collecting feedback from users and workshopping different features and improvements that would make the software better. So I really hope that if you're a user, your interest has really been piqued by some of these new features, and we really welcome your questions and feedback regarding the new RSCAD. I do want to mention that this initial release of RSCAD FX is focused mostly on the draft environment. We sort of rolled in the file manager screen into the draft environment, and draft becomes the central module for RSCAD FX. So that's where the majority of the updates are for this release. We also updated the component builder module with this release, which I will show you quickly today. Runtime will be the next module to receive major updates. So that's in the pipeline for the medium term. The goal of today's demo is to walk you through the new GUI, to orient you and to show you where you can find various features and functionalities. It's quite different with our new tab system, lots more toolbars and menus, and also the component library is quite different. So I'll go through that as well. But once you're oriented, it's really so much easier to use, so hopefully after this webinar, you will be off to the races in the software. Beyond that, I want to highlight the major features that really improve the user's productivity in RSCAD FX. I'll go over the Scratchpad, as well as wire mode and auto naming, which are big time savers when assembling and compiling a case. And along the way, I'll try to show some tips and tricks as well. If you have already watched the 6 RSCAD FX tutorial videos that are available either as a download from our client area or for streaming on our YouTube channel, then today we'll have a lot of repeated material. I'll try to cover a few new things and show some tips and tricks that I don't show in those videos, but if you've seen them, then today will be a lot of review. Okay, I'm going to start the demo. If you are an RTDS user with current access to our support website, then you should have received an email stating that RSCAD FX is ready for download, and it can be downloaded from the support area just as you would normally download an updated release of RSCAD. Your first impression of RSCAD FX is likely that it's quite different from V5. I'm no longer opening the software and looking exclusively at File Manager. File Manager is now incorporated into this main window, which also includes the draft canvas. So I can see my canvas on the right-hand side of the screen by default, and I have some tabs on the left, including the library, and there's the File Manager tab as well. I have a global drop-down menu at the top of my screen, as well as a global icon toolbar. And then I also have toolbars that are specific to the different tabs in my window, like the Case tab here or the Library tab. And I'll explain those in a moment. So I will begin by opening a case. There's a few different ways we can do this. If I navigate to my File Manager tab, I can see I have a few different submenus here. My user directory, tutorial cases, and example cases. And the File Manager is just pulling these files from the user directory that you specified during the setup wizard. And you can also change that in the global settings in the file drop-down menu. I'm going to open the Chapter 1 tutorial case, which I can find here. And the tutorial cases in RSCAD FX are not read-only, so you can actually alter the tutorial cases and save them, and they'll stay in this folder. And if you ever want to revert to the originals, you can right-click on tutorial cases and click Reset. Alternatively, I can open a case by clicking File in the drop-down menu and then Open. And I can also do it by using the keyboard shortcut Control and O. Related to keyboard shortcuts, if I click on Help and open the Quick Start Guide, we've prepared this document which is specifically targeted at giving a primer to the new features of RSCAD FX. So wire mode and auto naming, which I will demonstrate today, are explained here. And Appendix E has a list of all the shortcuts that are available on the keyboard in RSCAD FX. I want to take a moment to discuss the tabs in the RSCAD FX window and how user configurable they are. The tabs on the right-hand side of the screen are referred to as case tabs. A tab is created for each new draft case that I open, and the active tab is highlighted in orange. The tabs on the left-hand side of the screen are referred to as utility tabs. I can see all the different available utility tabs if I click on View, Utility Tabs, and they include the component library, the Scratchpad, compile messages, and file manager. I apologize for any puppy noises in the background of my audio. So I can change the position of any of these tabs by clicking on the tab title and dragging, and I'll see the screen shows a preview of where the tab would be dropped. So I can kind of use that to customize my window. I think clicking and dragging is probably not that intuitive for people who have been using RSCAD V5 for a long time. So just keep in mind that click and drag is very much integrated into FX. So I'm dragging my tabs around. I can also undock them by right-clicking on the tab title and clicking undock, or by clicking on this little undock pane icon. And that will pop the tab out so it becomes its own window effectively within the RSCAD FX program. I can see down here in my taskbar. You might be wondering where the messages tabs are that I saw in the view menu earlier. And they're actually down here. So they're represented by these small icons at the bottom. If I click on those icons, I can open up the tabs. And I can re-minimize them by clicking on the minus sign here. And any other tabs can also be minimized, and you'll see an icon appear at the bottom to represent that tab. At any point, if I want to reset the configuration to the original, I can click View in the drop-down menu, Reset Perspective, or I can click this Reset Perspective icon in the Global Icon menu. And you've probably noticed if I hover over the icons, it gives me a little tooltip with the name of the function, so that's helpful as well. Now let's take a look at how to move components around in RSCAD FX. I'll start by arranging my case tabs so that I can easily see the two tabs, and I'll move some components between them. And I'm going to do this with auto-naming incrementation turned off, just to prevent any premature questions about auto-naming. So we'll turn that on later. I want to start by copying this angle difference meter from one case to the other. Right now, these controls components are all grouped together. If I wanted to ungroup them, I can click on the group and hit Control-G on my keyboard, and I can see that it degroups those components. In RSCAD V5, we used hotkeys to achieve this, and those are still available as well. So if I want to try that again, I can use the G key on my keyboard by itself, and that hotkey will group and degroup. For me, the most convenient way to create a copy of this group and copy it over into the other case is to make sure the group is selected, and I can click Control on my keyboard, hold it down, and then click and drag the group into the new window. And holding Control while I click and drag will create a copy. I can also do this by selecting the group and then using the keyboard shortcuts Control-C and Control-V, or by using the hotkeys C and V. So there are a few ways to do things in RSCAD FX, and as you get to know the program, you can use whatever way becomes most convenient or intuitive for you. By the way, I should also mention that I can manipulate a group of components while it is degrouped. I'll show that by clicking and dragging to create a box around these components. Now they're all highlighted. I just have to make sure that I'm clicking on a component, not on the white space between components. So Control, if I click on the white space, I'm not able to move it. If I hold Control and click on a component, they all move together. I can explore some of the other shortcuts and hotkeys, for example, the delete key to remove a component from the canvas. There is Control-R to rotate a component. Make sure the component is selected, and then I'm clicking Control-R as many times as I want to rotate it. At any time, if I want to save my case, I can hit Control-S, and we have Control-Z and Control-Y for undo and redo respectively. And that brings me to the Case tab menu. I'll just amalgamate these case tabs again. And each case tab has its own icon menu. So I can achieve some of those functionalities like save, undo, and redo via this menu. I also want to draw your attention to the updated compile button. It now looks like a hammer, and it's right beside the rack or chassis drop-down menu, so you can choose your target rack and then compile your case. We have the launch runtime button here. We won't be looking at runtime today because, as I mentioned, it hasn't had much of an update, but we will have a future webinar about that once it has been overhauled. There's various other familiar functionalities here, like invoking a load flow or looking at the processor assignment chart. I do want to draw your attention to this little drop-down. As I hover over it, I can see View Compiler Output, and here I can access my DTP, info, map, and compiler log files. I'll also show you the Case Settings menu. You can click this icon here. And this is where you can set your simulation time step and adjust a couple of other settings for the case as well. And most of these functionalities can also be accessed from the drop-down toolbar just above the icon menu for each case tab. The last thing I'll mention about the case tabs is that previously in RSCAD V5, the user could choose between single line diagram or three-phase mode when they're building their case. And in RSCAD FX, all cases by default are built in single line diagram mode. We have a breakout component, so you can still build out on a single phase basis, but that is something to note. All right, let's take a look at our component library. So right away, I can see that the library has multiple panes. The pane on the left provides navigation, and on the right, we're displaying the components that are available. I can expand or collapse the master library, user library, and search results, which are grayed out because we haven't used the search functionality yet, by clicking on these drop-down titles. And looking at the master library, something that's quite different in RSCAD FX is that we are offering these tile icons to represent our components. So these tiles we're seeing now are categories, and I can click either on the category tile or on the category itself in the navigation tree to see what's inside. And each component is represented by a tile. This is a simplified graphic of the component. If I hover over the tile, I can see the actual graphic that would be added to my circuit. This just makes it a lot easier to compare and view all of my different components at once. I can see that the tile graphics are also varying colors, and that's because the components are categorized by color. So if I open my Quick Start Guide, I can actually view a table that shows the different component categories. So main step and control components are black, single phase components are blue, substep in brown, and more. So if I want to bring a machine into my case, I'll go to the Machines menu. I can double click on the library tile to open up a preview of the parameters for each component. I can't actually adjust the parameters here because this is a non-editable version of the component. But to bring it into my case, I can simply click the component, drag and drop. And once it's been dropped into my case, I can open it up or have it selected and use the keyboard shortcut Control-E for edit, and I can then edit the parameters. I can change the size of either library pane by clicking and dragging once I see the arrow icons. And I can also collapse the navigation pane entirely by clicking on this little arrow icon. I can also navigate the library left-hand pane using the arrow keys on my keyboard and using these icons in the library toolbar. So these icons can take me back or forward within the library or up a level. I can also hit the refresh button if I want to refresh the definition files for the master library components. We have the capability to filter our library components. It's turned off by default, so I can turn it on by just clicking the filter components icon in the toolbar, and the slash through the icon will go away. And then when I expand the icon, I see that I can filter by simulation environment or by phasing. So if I want to display, for example, just components in the substep environment, I can click the All checkbox to go to None, and then click Substep. And I can see that I'm only displaying components that I'm able to use in the substep. In my navigation pane, the small time step components, TWRT, GPES, and distribution components are grayed out. They're not available in the substep. If I want to filter it even further, I could choose to show only single phase components. One thing to note, and I can show it here by clicking File and opening a new distribution case. When I do that, the filtration is automatically turned on, and the library will only display components that are available in the distribution environment. And those filter settings will revert to previous when I have a case open that is non-distribution. Before we move on to the user library and search results, I'd like to point out the Quick Access toolbar, which is an extension of the master library. And that shows up on the right-hand side of the draft canvas, and it can be enabled or disabled using the Q icon or the keyboard shortcut Control and Q. The Quick Access toolbar contains a few key, commonly repeated components like node and bus labels, jumpers for drawing wires, and some different controls components. You can actually adjust which components are available to you in the Quick Access toolbar by clicking View Toolbar Configuration in the top drop-down menu. And then you can generally configure what is displayed in the various toolbars of RSCAD FX. So it's a pretty customizable interface. And like the tab configuration within your FX window, you can also reset the toolbar configuration to default by using the buttons that are available here. So for using the Quick Access toolbar, it works a little bit differently than the master library. If you click on a component, it will stick to your mouse, and then you can drop it onto the canvas. If you double-click a component, it will stick to your mouse and allow you to place multiple versions of the component onto the canvas. And if you'd like to unstick the component from your mouse, you can hit the Escape key on the keyboard. And that works as well anytime you're working in draft and you'd like to unstick a component to your mouse. Escape is the button to hit. Now let's take a look at the user library. So I can expand the user library dropdown in the library navigation pane, and here I'll see any folders that exist in my user library directory. And again, this is just looking at the user directory that is specified for RSCAD FX. For me, it's this folder here, and it's within this ulib folder. So if I want to import a RSCAD library file, a .lbx file, I can do that by just moving the folder into that folder on my PC and then opening RSCAD FX after having done that, or I can right-click on the user library tab title here and click Import Library. I'll show you how to create a new library or folder here. Where you right-click determines the location of the library or folder in the file hierarchy. So you can right-click here on User Library and create a library or folder at the very top level, or you can create something within another folder. So I'll create a new library at the top level. I can rename my library. Now, if I want to add components to my user library, first I need to make sure that the user library is unlocked and it's in editing mode. Right now, I look at the lock icon, I can see it's set to lock. If I click it, the library is now unlocked and I can make my changes and save them. So I will click and drag a component over from my draft canvas, and I can see that it's brought into the user library and it's now available as a tile. I can also add components by right-clicking on some white space and clicking Add Component, either from my user component definition file directory or from the master library. If you're having trouble adding components to your unlocked library, make sure that your filter is off and that the master library has all of the components available. It's important to re-lock your library before you start adding components from your user library to your canvas, because while the user library is in editing mode, while it's unlocked, if I drag a component out of that library, it actually removes it from the selection. So I need to lock my library, and then I can see that when I'm pulling components out of it, they remain available in the user library. All right, let's take a look at the Search Results tab here. To populate it, I will click into my search bar and type a query and press enter. Once I've done this, the query will be added to the search results area, which saves the most recent 5 searches. If I click the search icon in the toolbar, I can see that I have some options for my search scope and the libraries that I'm looking in. If I ever want to save my search results, I can right-click on the query and copy, and then paste it into user library. In general, in RSCAD FX, we've tried to implement as many shortcuts and right-click functionalities as we can, so definitely take some time and explore all the different menus and toolbars. All right, next I will explain the Scratchpad utility tab. Essentially, we developed this Scratchpad tab because of the way that we've implemented the component library in RSCAD FX. So previously in RSCAD, if you needed to keep some components handy, perhaps a configured component or a couple of models that were connected together, you could copy them into the master library for safekeeping. And that is no longer possible with the way we've done the master library in FX. So we implemented the Scratchpad to take care of that functionality. So I can move components into the Scratchpad, either individual components or multiple components connected together by dragging and dropping from my draft canvas. And they'll be conveniently stored there with the parameters saved and with the original graphics. I can use this icon in the Scratchpad toolbar to save my Scratchpad page. And once the page is saved, it will be accessible from this drop-down menu. I can also use toolbar icons to delete the page, to undo or redo, to search within the Scratchpad, and also to import. So the user can import existing Scratchpad files. The file extension for these is .spx, or RSCAD v5 library files can also be saved into the Scratchpad. And if I close the Scratchpad or the RSCAD FX software, these pages will be still available when I reopen it. All right, next I'm going to demonstrate wire mode. And we developed wire mode to make the process of connecting components and laying out your circuit with buswork in RSCAD to be much easier and much faster. I can turn wire mode on by hitting this icon in the draft case toolbar, or I can also use the shortcut Control and W on my keyboard. And I know that I'm in wire mode because my cursor changes to a pencil icon, and then I can start drawing my buswork. Beside the wire mode icon, we have 1- and 3-phase icons, so you can choose what type of wire you're drawing. We will draw with 3-phase for now because it's going to be the most common way to connect power system components in RSCAD. But there's also the single-phase option, and I'll show how to use the breakout component. And single-phase wires can also be used to connect controls components. So they'll make the process of building out your controller much, much faster. So to begin drawing my wire, I set the starting point by clicking once on the draft canvas and immediately releasing the mouse button. So I'm not holding my mouse button down here, and the wire will stick to my mouse. So I can move my mouse around the canvas and I can see it brings the wire with it. And clicking once on the canvas again will end the current wire segment and immediately stick a new one to my mouse. And clicking once on the canvas again will end the next segment, and so on. So this is a series of single clicks and mouse movements to create a complex wire segment. At any time, I can press the escape key on my keyboard, and that will delete the current segment I'm drawing, but keep the previous segments, and it will keep me in wire mode. So I can single click again on a different part of the canvas to draw another wire. To end a segment but remain in wire mode, I can double click. So I'll show that here. An alternative to double clicking, I can hit enter on my keyboard. I think clicking is a little bit easier. You kind of get in the flow of single and double clicks to create your wires. Now, if you attempt to directly connect a three-phase wire to a single-phase wire, you will get an error. And to properly do this, you need to use the breakout component. So again, I can single click to stick one to my mouse, or double click if I want to place multiple breakout components. And then I continue using wire mode to build out my circuit. If wires overlap like this, RSCAD will assume an electrical connection. So we need to use jumpers in this scenario to provide separation between the wires. And there's a couple of ways to do that. By default, the jumpers are located by the breakout component in the quick access toolbar. So here I have the 3 single-phase jumpers at the top, and then I have my 3-phase jumper. So again, I can single click for one jumper or double click if I need to place multiple jumpers in my circuit. The second way to use jumpers, which is really convenient, is by right-clicking my mouse when I'm in wire mode. So if I'm in 3-phase wire mode, at any time I can right-click my mouse to stick a jumper to it. I can do that while I'm drawing the wire and then continue drawing by single-clicking again to start the new segment. And similarly, if I'm in single-phase mode, it will provide a single-phase jumper when I right-click. And while the single-phase jumper is stuck to my mouse, I can actually right-click again, and it will show me a 2-wire jumper, and again, and it'll show me a 3-wire jumper. So you can cycle through the different available jumpers by making multiple right-clicks. And again, hitting escape at any time will unstick the component from your mouse. And by the way, you can still draw buswork in a more conventional way. You can seek out the wire component from the component library. I'm dragging it into my case. I can use this drag functionality on the component to change the width, and then I can use my Control and R to rotate it. But I think you'll find that wire mode is just significantly more convenient. And compared to RSCAD V5, it makes laying out your circuit so much faster. This is the kind of situation where it's handy to be able to quickly grab jumpers and lay out both 3-phase and single-phase wires. All right, the final feature I'm going to demonstrate is the auto-naming feature. And auto-naming can seem a little bit complex at first, but it's actually quite straightforward, and it's very, very useful once you wrap your head around it. In RSCAD V5, a very common source of errors in the draft environment was name repetition. So using many like components with many like signal names, you had to go in and manually change each name. And auto-naming is what we've developed for RSCAD FX to make the unique naming process automatic and much easier. When auto-naming incrementation is turned off, which it has been for this demo so far, this is what happens when I copy a component over or use multiple versions of the same component from the library. You can see the component name is the same. It's easy to see with the source because it's displayed here on the canvas. And also the signal names within the component are the same. I haven't turned monitoring on here, so the names are grayed out, but you can see IA, IB, IC, and in this component, they're the same. Now I'm going to turn auto-naming incrementation on and watch what happens when I copy over the source component. I'm using my Control key on my keyboard and clicking and dragging. So the name of the component is updated, and the signal names are also updated. So these components are now uniquely named in terms of the component name and the signal names within. And if I had a case with just these components, I could compile and I wouldn't receive any name repetition errors. So let's take a look at how exactly that works. The main concept behind auto-naming is something called the enumerator. So each instance of each component in RSCAD FX has its own enumerator. And auto-naming works by incrementing the enumerator of components. It's important to realize that the enumerator exists in the component whether or not auto-naming incrementation is turned on or off. The enumerator is always there. It's just when you turn on the incrementation, that's when auto-naming takes effect to increment that enumerator and create a unique name. So if I open up a component and take a look at most of the character fields, that is the parameters where typically you're entering a name. I can see this small highlighted portion, and that represents the enumerator. And if I open up this source component that I placed on the canvas when auto-naming incrementation was turned off, I can still see that the enumerator exists. It just wasn't incremented at the time. So you can see that when a field with the enumerator is not being edited, when I've clicked outside of the field, it shows the enumerator's current value. But when I click into that field to edit it, I can see that the enumerator is represented by a number sign. And that number sign is a reserved character. It's used only for auto-naming. So anytime you see that number sign, it is representing the enumerator. And it's included by default at the end of most character fields, most text fields in the parameters, but the user can move it around. So here I'm moving the position of that enumerator within the character field, and when I save the component, it will update the name. I can also remove the enumerator from a character field completely, and that will mean that auto-naming incrementation does not affect this particular field at all. We can take a look at how auto-naming works in different cases and with the library now. So note that when I open a new case tab, the auto-naming incrementation on/off icon is global. So when I've toggled it in one tab, that takes effect in other tabs as well. In this case tab, I'll show how auto-naming incrementation works when I'm pulling components from the library. So when I grab a source from the library here, I can see that the incrementation starts again in the new case. So it's not picking up where it left off in the old case, and it continues to increment as I pull the component directly from the library. And again, I can turn incrementation off, and you'll see that turning it off does not remove the enumerator, it simply stops the incrementation process. The user has a lot of control over how the enumerator is displayed. So let's take a look at this. Every component that has at least one field where an enumerator is added will have a section titled Auto-Naming Settings in its component parameters. And these settings can also be accessed from the right-click menu on the component, but for now we'll go into the parameter menu. First of all, I can manually set the enumerator value for this particular instance of this component by entering a value here in this text box. And you can see it previews the enumerator in a few different ways. The program sees it as an integer that is incrementing, but it can be interpreted and displayed as a decimal or hexadecimal number or as a letter. So that's what it's showing here. To change the interpretation, I can modify the enumeration type dropdown. So if I change the interpretation to lowercase letter, for example, I can copy and paste components and the enumerator will continue to increment with that given type because that enumerator type property is being copied with the component. We also have a reset button here, and clicking this will reset the current value of the enumerator for this component to 0. And it will then be evaluated as an empty string. So if I reset the enumerator and then I copy and paste the component, it basically starts a new string of incrementing enumerators. And I can reset the enumerator for library components as well. I just need to find a blank space in the draft canvas, right-click, and then click Reset Auto Naming from Library. Now, when I go back and pull from the library, I start with a fresh series of incrementing enumerators. This enumeration string field basically allows the user to customize the enumerator so that it contains other characters other than the number sign. So you can add leading and or tailing characters, and back in the component parameters menu, the enumerator will still appear as a number sign that represents the entire string. But when I'm looking at the current value, that string will now include those additional characters that we specified. So here I'm showing auto naming incrementation with a custom enumerator string. Clicking Flatten Signal Names will flatten the current enumerator value into the parameter name. So previously we had a valued enumerator that is now incorporated into that flat non-incrementing parameter name, and we re-add the enumerator to the end of that flattened string. It's given a value of 0 so that the enumerator part evaluates as an empty string, which means that once we've flattened that name, we can copy and paste the component, and the flattened name will stay static while this new enumerator will be incremented. Flattening can be helpful when we copy and paste a group of components. So auto naming works on a per component basis, which means if I just copy and paste a group of components with incrementation on, like I'm doing here, I can end up with some duplicated component names because auto naming is incrementing the names for each component. If I want to prevent that, I can select the group of components, right-click on one of them, and click Flatten from the right-click auto naming menu. And then copying and pasting the group will result in a new group of uniquely named components, like you can see here. So that flatten action was applied to every component in the group, and now I don't have to worry about name duplicates. The last aspect of auto naming that we'll discuss is enabling or disabling auto naming on a per component basis. So separate from the global toolbar icon, we have auto naming enabling or disabling in each instance of each component in the settings menu. So when I disable auto naming for this component, any character field for the component that has the number sign will evaluate that symbol to an empty string. It doesn't remove the enumerator, and it doesn't even stop it from incrementing. It simply evaluates it to an empty string. So disabling auto naming on a component basis is very different than turning the incrementation off using the global toolbar icon. And I think to use auto naming effectively, you need to understand the difference. So here I will copy and paste a component with auto naming disabled, and then I will select the group and re-enable auto naming using the right-click menu. And you can see that the enumerator was present and incrementing while auto naming was disabled. Disabling simply evaluates it and displays it as an empty string. So those are the basic principles of auto naming. I'm going to open up a case here so we can quickly see it in action, more in practice. So this is the Chapter 5 tutorial case for the induction machine. I'm going to start by compiling it. Okay, that was successful. And now I'm going to go ahead and take some steps to copy this whole circuit and paste a duplicate within the same case and then compile. If I was doing this without auto naming in RSCAD V5, I would have to individually change not only the component names, but all the signal names. So here we'll really see auto naming in action. So first I'm going to select the circuit and flatten the auto naming so that the pre-existing enumerator values are now included in the flattened parameter names, and a new enumerator has been added to the ends, and that happened for every component. And now I can zoom out, and I'll increase my canvas size here. And I can use the control and drag to create a copy of my circuit, keeping in mind that auto-naming incrementation was turned on when I did so. So if I zoom in, I can see that my source now has a unique name. We took that flattened name and we incremented an enumerator at the end of it. Now I can try to compile again, but I'll receive an error. And by the way, when I'm checking out my compile messages, I can actually select which case tab I want to view messages for. So I'm here in my induction machine case tab, and more than one node is named N11. So this is a classical unique naming error. And the reason is that when we incremented one of the bus names, there was actually already a node 11 in the case. So we need to find a way around that. A good way to do that is to select the copy case, right-click auto naming, enumerator set type, and we'll change the enumerator type to letter. And now I can see I have completely unique names all throughout this circuit. So now I'll try to compile once more, check my errors. Okay, the error I'm seeing is related to the T-line constants file name. So if I go to my T-line calculation block, this T-line constants file name was incremented with auto naming, but of course the actual name of our T-line constants file hasn't changed. So we need to be referring to the proper file. So I'll delete those. And I'll compile. And my compile has completed successfully. So there were a few things to work out, but the whole process was much easier and required so much less user intervention now that we're using auto naming. Now before we get to the Q&A, there are actually a couple more little things I want to show. I'll open up the component builder, and you can see it looks quite different as well. It's been updated. We have a new suite of icons and menus. It's also really easy to drag shapes around the canvas and to manipulate them. Here in the Shape drop-down menu, there are several actions that can be taken on the drawing canvas along with their new keyboard shortcuts. So if you use CBuilder a lot, definitely familiarize yourself with those. That's a big time saver. The programming and association part is really the same, but the interface is much more intuitive. And as I mentioned before, the runtime, T-line, and cable modules look the same as they did in V5, but they'll eventually be updated as well. The Utilities drop-down menu is where you can find the config file editor, which looks the same, firmware and diagnostics, and a few of our other built-in utilities like conversion tools. A couple things to point out. We've added this utility called the Case Comparison tool, which runs a comparison between two draft cases and creates a text output which identifies the differences line by line. Also, if you're doing protection and automation work with RSCAD FX, there is no more SCD editor in RSCAD FX. It's been replaced with our newer version, which is called the IED configuration tool, or the ICT. It's been updated in terms of both look and feel and functionality, and it's fully documented with a help manual. Finally, you might have noticed that the draft files in RSCAD FX have a different file extension here, .dfx. And if I'm to open a previous version of RSCAD draft file, a DFT file, it will prompt this conversion tool, which converts DFT files to DFX files automatically. So once the conversion is complete, you can then open the draft file in RSCAD FX. That concludes our webinar and demo for today. So thank you so much everyone for your attention, and we will now take your questions.